Assalamualaikum and hi everyone. This video will show you on how to solve the example questions step by step for chapter 4 forces. Alright, let's get started. Example 4.1. Apply first Newton's law of motion. A box of mass 20 kg is on a rough horizontal plane. The box is pulled by a force F which is applied at an angle of 30 degrees above horizontal as shown in figure. If the coefficient of static friction between the box and the plane is 0.3 and the box moves at a constant speed, calculate A, the normal reaction force, B, the applied force F, and C, the static friction force, given G equals to 9.81 ms negative 2. Alright, so the information given is mass of the box, which is 20 kilogram. Okay, and then mu s, which is the coefficient of static friction, is 0.3. Okay, and the most important keyword in this question is constant speed. Okay, so this means that the acceleration is 0. Okay, alright, so to solve the first question, which is to find the normal reaction force, as usual, we have to draw the free body diagram. Okay, so we draw the free body diagram. Okay, before that, let's write down that the A is equals to 0. So this means that summation Fx equals to 0 and summation Fy also equals to 0. Okay, so let's draw the free body diagram. Okay, first we have the weight, and then we have the normal force, and then we have the applied force F, which is 30 degree from horizontal, and do not forget the frictional force. Okay, static frictional force Fs, which is in the opposite direction of the applied force. Alright, so now let's resolve the forces into its components x and y. Okay, so resolve summation Fy equals to, let's resolve summation Fx equals to 0. Okay, kita buat summation Fx dulu. Summation Fx equals to 0. Alright, so kalau kita tengok dalam free body diagram ni, F kita ni bersudut 30 degree. Okay, so F ni pun kita boleh resolve into x and y juga. So ini akan jadi Fy, and this one will be Fx. Okay, so Fx equals to F cos 30 and Fy is F sin 30 degree. Okay, so now let's solve our equation. So summation Fx equals to 0. So forces acting in x direction based on this free body diagram, we have Fx and Fs. Okay, so Fx minus Fs equals to 0. So Fx is F cos 30 minus mu s n equals to 0. Okay, so F cos 30, okay, given mu s is 0.3 and equals to 0. Okay, so rearrange the equation. So we'll get F equals to 0.3 and divide by cos 30. Okay, so this is our first equation. Okay, so now let's resolve into y component. Okay, summation Fy equals to 0. Forces acting in y direction, we have N, we have Fy, and also W. Okay, so N plus Fy minus W equals to 0. So n plus f sine 30 equals to 20 times 9.81. So okay, so now so this is our second equation. So now let's substitute first equation into second equation. So we'll have n plus f is 0.3 n divided by cos 30 times with sine 30 equals to 196.2. Okay, then we will get the value of n equals to 167 Newton. Okay, so dah dapat soalan pertama. Okay, so soalan yang kedua minta kita cari the value of the force F. Okay, so untuk soalan yang kedua kita nak cari F. So kita just masukkan value of n yang kita dah dapat kat bawah ni ke dalam equation yang pertama. Okay, masuk dalam equation pertama boleh, equation 2 pun boleh. Okay, kita still akan dapat jawapan untuk F. Okay, so untuk mudah saya ambil equation yang pertama, F equals to 0.3 n divided by cos 30, and the value of n that we have calculated in question 1 is 167 divided by cos 30. So we'll get the value of F equals to 57.9 n. Okay, settle soalan 2. Okay, soalan yang ketiga. Soalan yang ketiga minta kita cari value of static frictional force. Okay, so which means kita nak tahu, kita perlu cari berapa Fs ni. Okay, kita tahu equation untuk Fs is mu s n, and given to you mu s is 0.3, just times with 167. Okay, so we will get the Fs is 50.1 Newton. Okay, that's all. Example 4.2. Apply Newton's second law of motion. 3 wooden blocks connected by a rope of negligible mass are being dragged by a horizontal force F as shown in figure. Suppose that F equals to 1000 Newton, M1 equals to 3 kg, M2 equals to 15 kg, and M3 equals to 30 kg. Determine A, the acceleration of block system, B, tension of the rope T1 and T2. Neglect the friction between the floor and the wooden blocks. Alright, so this means that there is no frictional force. Okay, so Fs equals to 0. Okay, so maksudnya tak ada frictional force between the floor and the block. Alright, so kalau kita tengok gambar ni, dalam gambar rajah ni, apply force ni is being applied to the left direction. Dia ke arah kiri, is being pulled to the left. So what will happen to this block? Okay, what happen to all of this block? This block will move to the left juga. Okay, sebab kita punya apply force ke kiri, is being pulled to the left. So all the block eventually will move to the left. So acceleration akan ke arah sinilah. Direction, maksudnya motion of the block will be to the left direction. So A kita pun dari sini kita dah tahu dah, A kita akan ke arah kiri. Alright, so untuk solvekan soalan yang pertama, untuk dapatkan value of acceleration, okay, so first of all we have to draw the free body diagram of each block. Okay, so since we have 3 blocks, so we're gonna have 3 free body diagram. Okay, in order to do that, we have to identify what are the forces acting on each of the blocks. Okay, so now let's draw the free body diagram. Okay, free body diagram for M1. Okay, lukis titik tengah. Okay, so kita ada mass, weight, so M1 G, and then we have normal force. Okay, we have normal force because the block is in contact with the floor. And then we have T1, the left and the right direction, and the apply force is in the left direction. Okay, so kita lukis free body diagram untuk M2 pula. Okay, so kita ada weight M2 G, we have normal. Okay, ini normal 2 lah. And then we have, oops, this is T1. So now here we have T2 in the right direction and T1 is in the left direction. And then for free body diagram block M3, we have the weight M3G, and then we have the normal force M3, and we have here T2. Okay, so macam kita tengok dalam gambar tadi, kita punya apply force ni ke arah kiri. So maksudnya motion block tu akan bergerak ke arah kiri. Okay, so kita punya acceleration macam saya bagi tahu, acceleration kita pun akan ke arah kiri. Okay, so maksudnya untuk free body diagram M1, A kita pun arah sini. Untuk M2 still in left direction and M3 also in left direction. Okay, so now we have to resolve the forces acting in X component. Sebab kita nak cari A dan kita tahu A ni juga in X direction, so kita resolve forces into X component. So saya resolve untuk free body diagram yang pertama dahulu. Okay, so summation Fx equals to negative MA. Okay, so kenapa saya letak negatif? Sebab kalau tengok dekat sini, acceleration kita is in left direction. Okay, since A is acceleration is a vector quantity, so this negative direction is just to indicate that the acceleration is acting in the left direction. Okay, itu sahaja. So kita resolve into X component. So kita tengok what are forces acting in X component. Kalau tengok dalam untuk free body diagram yang pertama, kita ada T1. Kita ada T1 minus F equals to negative MA. Okay, T1 minus F given to you is 1000 equals to negative 3A. Okay, so we rearrange this equation, so we will get T1 equals to 1000 minus 3A. Okay, so this is our first equation. Okay, so now kita resolve force into X component for free body diagram yang kedua. Fx equals to negative MA. Okay, forces acting in X direction, kita ada T2 dan juga T1. Okay, so T2 minus T1 equals to negative 15A. Okay, so T1 kalau tengok kita substitute equation 1 into this equation, so T2 minus 1000 minus 3A equals to negative 15A. So T2 minus 1000 plus 3A equals to negative 15A. Okay, so rearrange this equation, so we will get T2 equals to 1000 minus 18A. Okay, so this is our second equation. Alright, so now let's resolve force into X component for free body diagram yang ketiga. Summation Fx equals to negative MA. So T2, okay, T2 ni di arah kiri, so saya letaklah negatif kat sini. So negative T2 equals to negative 30A. Okay, so negative cancel out, so T2 equals to 30 A. Alright, so saya substitute second equation. Okay, so saya substitute. Okay, so this is our third equation. So saya substitute second equation into third equation. Okay, so we will get T2 is 1000 minus 18A equals to 30A. So A, okay, solve this equation, rearrange, and we will get A equals to 20.8 ms negative 2. Okay, so dah settle soalan pertama. Soalan pertama minta kita cari acceleration dan kita dah dapat value of acceleration is 20.8 ms negative 2. Alright, so untuk soalan yang kedua minta kita cari value of T1 and T2. Okay, so apa yang kita buat sekarang is kita masukkan value of acceleration ni ke dalam equation 1 and equation 2. Okay, so to solve question 2, just substitute the value of A into equation 1 and 2. So T1 equals to 1000 minus 3 times 20.8. So we will get the value of T1 is 937.6 Newton. Okay, and then for T2 equals to 1000 minus 18 times A. Okay, so we will get T2 is equal to 625.6 Newton. Okay. Example 4.3. Apply Newton's second law of motion. Figure 4 shows a block of mass m1 6 kg on a horizontal surface with coefficient of kinetic friction μk equals to 0.22 is connected by a string through a pulley to another block of mass m2 equals to 3 kg. The system is released from rest. Okay, so question 1 asks you to draw forces acting on the blocks, okay, when they are in motion. Calculate the acceleration of the blocks, and 3, calculate the tension in the string. Okay, so kalau kita tengok dalam gambar ni, block M1 and M2 ni is being connected by one rope. Okay, sebab dia pakai pulley system. Okay, so since yang ni adalah pulley system, so ni, tali kat sini dengan tali kat sini adalah tali yang sama. Okay, so kalau blok ni in motion, kalau secara in motion, so dia akan bergerak macam mana? So dia akan bergerak, for M1 akan bergerak ke arah kanan dan for M2 dia akan turun macam ni. Nah, ini motion of the block. Ke kanan dan turun ke bawah. So acceleration untuk M1 akan ke arah kanan dan acceleration untuk M2 akan ke bawah. Alright, so jom kita lukis free body diagram untuk M1. Okay, free body diagram M1. Okay, first we have the weight M1G. Oops. And then we have normal force. Okay, because the block is in contact with the surface. And then we have tension in the right direction. Okay, then kita ada frictional force. Okay, frictional force is in the opposite direction to the tension. Okay, so FK, saya tulis FK sebab memang dalam soalan dah diberi value of μk, coefficient of kinetic friction. Okay, so sebab tu saya tulis kat sini FK. Alright, okay, so now kita lukis free body diagram untuk M2. Okay, untuk M2 kita ada weight M2G, and then we have T. Alright, so ini soalan yang pertama. Kita dah lukis forces acting on the block when the block is in motion. Alright, so untuk jawab soalan nombor 2, minta kita cari value of acceleration. Okay, so untuk soalan yang kedua, kita nak cari value of A. So, kita perlu resolve forces ni, into its component, which is X and Y. Okay, untuk free body diagram yang pertama, saya resolve dulu summation Fy equals to 0. Okay, kenapa summation Fy equals to 0? Sebab untuk blok M1, motion dia ke arah kanan. Maksudnya A kita ke arah kanan. Okay, tak ada motion secara Y. Okay, sebab tu summation Fy equals to 0. Sebab kita punya A is in X direction. Summation Fy is equals to 0. Okay, so kita resolve summation Fy equals to 0. So, we will have N minus M1 G equals to 0. So, N equals to 6 times 9.81. So, we will get the value of normal force. N is 58.86 Newton. Okay. Dan resolve ni, kita resolve pula into Y component. Okay, so summation Fx equals to MA. Ni summation Fx ni baru equals to MA sebab motion kita in X direction. Okay, so T minus Fk equals to MA. T minus mu Kn equals to 6A. Okay, so T minus 0.22 times with 58.86 times equals to 6A. Okay, so kita rearrange this equation. So we will get T equals to 6A plus 12.949. Okay, so ini adalah equation yang pertama. Okay, alright. So now kita solvekan pula. Kita resolve untuk free body diagram M2. Okay, so now yang ni akan jadi summation Fy equals to negative MA. Sebab A kita untuk M2 dia ke bawah. Sebab tu jadi negatif. Alright, so T minus M2G equals to negative MA. Okay, T minus 3 times 9.81 equals to negative 3A. Okay, so rearrange this equation. So we will get T equals to negative 3A plus 29.43. Okay, so this is our second equation. Okay, so now kita equatekan lah, kita samakan. Okay, kita samakan equation 1 equals to equation 2. So kita akan dapat 6A plus 12.949 equals to negative 3A plus 29.43. Okay, so it will be 9A equals to 16.481. So A equals to 1.83 ms negative 2. Okay, alright. So kita dah dapat dah value of acceleration equals to 1.83 ms negative 2. Okay, so now kita kita solve soalan yang ketiga, which is tension. Question asks you to calculate the tension in the string. Okay, so kita masukkanlah value A ni. Value A equals to 1.83 ms negative 2 ke dalam equation 1 boleh, equation 2 pun boleh. Okay, So saya masukkan value of A into first equation. So T equals to 6A plus 12.949. Okay, so 6 times 1.83 plus 12.949. So T is equal to 23.93 Newton. Example 4.4. Apply Newton's third law of motion. Two blocks A of mass 10 kg and B of mass 30 kg are side by side and in contact with each other. They are pushed along a smooth floor under the action of a constant force F of magnitude 200 Newton applied to A as shown in figure. Okay, so determine A, the acceleration of the blocks, and B, force exerted by A on B. Alright, so info yang diberi, mass untuk A is 10 kg and B is 30 kg. Constant force is 200 Newton and also the floor is smooth. Okay, so smooth floor maksudnya smooth surface tak ada, kiranya tak ada frictional force. Okay, frictional force equals to 0. Alright, so kalau kita tengok gambar ni, constant force ni is being applied to the right. Okay, it's being applied to the right. So block A and B akan move to the right juga. Okay, block A and B pun akan move to the right. So untuk soalan yang pertama, soalan minta kita cari acceleration of the block. So yang ni sebenarnya adalah kita kena cari net acceleration. Kita kena cari berapa value of acceleration yang diperlukan untuk menggerakkan kedua-dua blok ini. Okay, so in order to do that, we have to consider block A and B ni as a one block. Kita consider block A and B sebagai satu blok. Okay, so kalau kita lukis free body diagram, so yang ni akan jadi M1 plus M2 times G. So yang ni adalah normal dan yang ni adalah F. Okay, so since kita nak cari value of acceleration dan acceleration ni hanya in X component, so kita resolve lah force, summation force, kita resolve force into X component, summation Fx equals to MA. Okay, sebab A kita ni in X. Okay, sebab tu kita resolve into X. Okay, so forces acting in X direction is just the constant force. Dan M ni adalah M total. M total. So, which means M1 plus M2 times with the acceleration. So, 200, 10 plus 30 times A. So, A will be 5 ms negative 2. Okay. So, both block will move at the same acceleration of 5 ms negative 2. Alright, so untuk question B, okay, determine the force exerted by A on B. Okay, so kita kena tengok, kalau kita tengok dalam gambar ni, okay, block A and B ni, dia in contact, dia side by side. Okay, dia side by side. Okay, so maksudnya kalau kita lukis free body diagram untuk block A, kita akan ada satu force exerted by B on A. Okay, kalau kita lukis free body diagram untuk block A, kita akan, maksudnya block A ni akan experience satu force exerted by B on A. Okay. Okay, dan kalau kita lukis free body diagram untuk block B pun, block B pun akan experience force exerted by A on B. Okay, so value FAB ni, FAB dengan FBA ni sebenarnya adalah sama. Cuma dia punya direction sahaja yang berbeza. Macam Newton third law. Every action force has a reaction force that is equal in magnitude but opposite in direction. Okay, so untuk solve soalan yang kedua ni, okay, kita lukislah free body diagram untuk A pun boleh, untuk B pun boleh. Kita still akan dapat jawapan yang sama. Okay, so untuk blok yang pertama, okay, free body diagram Untuk A, okay, this one will be the weight, okay, normal, and then we have F in this direction, dan kita ada FB A. Okay, maksudnya block A ni akan experience force exerted by block B on A. Okay, sebab apa dia experience force exerted by block B on A? Sebab dia in contact dengan block B. Okay, so apa-apa block, apa-apa objek in contact with any surface atau any floor, dia akan experience satu force. Itu yang kita panggil sebagai normal force lah. Okay, so sekarang ni kita cari berapa value of FBA. Okay, so kita resolve into X, summation Fx equals to MA. Okay, summation Fx equals to MA, F minus FBA equals to 10 times 5. F is 200 minus FBA equals to 50. So we will get force exerted by B on A is 150 Newton. Okay, so cuba kalau kita cari force exerted by B on A ni by drawing free body diagram. Free body diagram untuk block B. Okay, so kalau kita lukis free body diagram untuk block B, okay, we'll have width P, this is N, and then we have F, force exerted by A on B. Okay, so yang ni kita resolve lah, summation Fx equals to MA. Okay, forces acting in X direction is just FAB 30 times 5. So we will get 150 newtons. Kita akan dapat jawapan yang sama. Kita akan dapat jawapan yang sama. Tu macam saya cakap tadi, ini adalah third Newton law. Okay. Dia punya value sama, tapi direction sahaja yang berbeza. Okay.